Now we should be good. Why isn't it loading here? Okay, looks okay. Cool. Okay. Let's post this. I'm just setting everything up here. Bringing all the screens into sync. Like that. Let's bring up the Discord like that, and then I can push it here as well. Okay, I think that's it, all of it. Good evening, everybody. Let's try and see if we can actually do Advent of Code day 13 this time, because I didn't before. Let me mute this and let's tell Luc. Let's see. Okay, so that should be that. Okay, so last week we did a JavaScript site. Well, it's not a JavaScript site, it was a flip challenge. Let's see, what was it? Flip flop. It was this thing. And we had some fun with that. And I did it in JavaScript because I just did it right in the browser. I originally planned to do Advent of Code, but I forgot. Well, I didn't forget, I just didn't get around to do it. Let me log in first. I think I'm logged in with my Google there. I always forget which social login I use to do it. So yeah, this should be the one that we do today. I haven't read it yet, so I hope it's not too bad. Everybody at home has been sick. Kids have been sick, wife has been sick, I've been sick for a bit, so... Hey Martin and Luc, welcome in the chat. Nice to see you both. But I'm sure I'll feel better in a few days. I haven't been as sick as the other people have been, so I think it will be fine. Just a little bit of a sore throat right now, so we'll see how the talking goes as the time progresses. But yeah, I hope everybody had a good week and had fun with whatever you were doing. I've been just working a lot, so it's good to relax a bit, even though I'm really looking forward to just going to bed in a few. So, hey Nineberry, welcome. Nice to see everybody again. So yeah, I think we'll just gonna go and read day 13, unless somebody has something that we want to share first. I don't think so. Yeah, I found something cool. I haven't fully read it yet, but it was like an improvement on Dijkstra's, I think, yeah, where they just did like a sub-optimation that in most cases resulted in a faster algorithm. So that was pretty cool. I thought I'd share it so everybody could take a stab at it first. But I will look at that, not today, but it's on my list of things to do, because it would be nice to have that going maybe for next year with the Advent of Code. And it's never a bad thing to practice your search algorithms when you like to do stuff like that. So yeah. Let's see. I think we're just gonna read day 13 now. Has everybody done this one yet? Do you know if it's a hard one or not? I remember taking the screenshot for my thumbnail and I was like, oh, this looks spicy. So I'm not sure yet what it is, but I hope we'll be able to have some fun with it. So yeah, day 13, a maze of twisty little cubicles. You arrive at the first floor of this new building to discover a much less welcoming environment than the shiny atrium of the last one. Instead, you are in a maze of twisty little cubicles, all alike. Every location in this area is addressed by a pair of non-negative integers, xy. Each such coordinate is either a wall or an open space. You can't move diagonally. The cube maze starts at 0, 0 and seems to extend infinitely towards positive x and y. Negative values are invalid. as they represent a location outside the building. You are in a small waiting area at 1-1. While it seems chaotic, a nearby morale-boosting poster explains the layout is actually quite logical. You can determine whether a given XY coordinate will be a wall or an open space using a simple system. Find x times y plus 3x plus 2 times x times y plus y times y. Okay. At the office designer's favorite number, your puzzle input. Find the binary representation of that sum. Count the number of bits that are 1. If the number of bits that are 1 is even, it's an open space. If the number of bits that are 1 are odd, it's a wall. For example, if the office designer's favorite number were 10, drawing walls as hashes and open spaces as period, the corner of the building containing 00 would look like this. Okay. Now, suppose you wanted to reach 7th floor. The shortest route you could take is marked as 0. Okay, blur. Okay. Thus, reaching 7th floor would take a minimum of 11 steps, starting from your current location 1. What's the fewest number of steps required for you to reach that location? Okay. Your puzzle input is this. Nice, nice. Marta says it's quite an easy task. Okay. Doesn't read like it, but the thing that I found funny was the binary representation thing, because it immediately gave me like a flashback to a few years ago when I remember that people did some smart things with the binary stuff of like getting how many bits are set, and I don't quite remember it, so I might go back into old code to look at if I can find like bits. Let's see. Bits per hex. Because there was like a way. Be dynamic length number. Not sure if that one was it. Sub packet length. No, that was not it. I just remember something from a few years ago that had a nice trick to easily get the number of bits in a number. And I don't know if it's just using the bit converter or if there was something else, but can't remember quite. Here, bit difference. Bit operations pop count. There you have it. Okay, that was it. So you could use this and diff it with, do just this just with 0, and then you'd have them. JanDev1000 says, yo, do you mind if you test out my website game? It's not quite the task of today, maybe later. But feel free to share it. I'll take a look if we have some time. I first want to try this advent of code. Let's see. It's just usual stuff, it's not difficult. Okay. But this one is interesting. See, it stuck with me because it was something that I wasn't familiar with. Number of bits of a mask. So let's... I like that one. I'm gonna... I don't think I've ever used it before, just for that. Like, yeah, right? Bits set. 2, pop count, and just pass it as a, yeah. Cool. It's using 24 as well. I just, okay, never mind. But bit operation of pop count is just an efficient way to get the number of bits. Okay, so let's make a day 13. And I should probably bring up the zoom here. Let's first reset it and then something like this. And we make a day 13 now. Bum, 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 ba, da, da, dum, dum. Okay, that is that part. So this one would be 11 steps for the test. It's funny, like there isn't even a puzzle input to get. So I wonder if you do the puzzle input getting thing, if that is returned there. So that should be interesting to see. Let's see, so I can do console, the right line, input. Let's run this. Marta says, I will return, it will return same number in the input it checked. Okay, cool. Bad request. Are you sure? But 400 could also be, okay. Let's make sure that it's not the session token. So we'll just do day 14 here. Maybe I need to refresh my session token. Yeah, okay. I probably just need to refresh my session token. Oh yeah, because I actually just logged in again. So let me just hide some stuff for now. And let me pull this up off screen. Application. Close all tabs. Bum, 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 bum. I didn't even look at the output. Yeah, that works. Okay. So I can switch back. Day 14 also has an inline input. Yeah, okay, but it worked. So it was the session that expired. And I actually have like the super over engineer. I don't know if I shared it. I think I made a video about that once, but I have, and I probably can't share any of the code right now because there's probably lots of secret stuff in there that I don't know if I want to share. But I had like a multi-stage payload thing that could, it was pretty cool. It would launch a process, a system, because you need it as, no, it would launch it as system, or it would launch it, no, it would launch as your current user. And then it would use protected storage to get a part of the data. Then it would launch a process as system via a scheduled task to get another part of protected data that's only available to system accounts. And I had like a whole, like with WebSockets that they could talk to each other so that they could relay between the processes, the data and the stuff that it needs to do, to get like the Chrome encrypted cookie, because that's really hard to get programmatically. So it would take an NTFS shadow volume copy of the file so that you could get the cookie data while the process was running, so you didn't have to kill it. Like I did so many things, and then a year later I checked it and they changed it again, and it was like already the second time that I did it because they added new layers of security, and so I just didn't have time to rewrite it again and dig into what they changed to set up the protection. But I think I made a quick video about how that works, so that will be on my YouTube. But I never went into the full details because I didn't have time to explain it. But that's these programs here. That's like it's almost like malware, because you have something that you start with elevated privileges. And then you have like use a scheduled task to launch a process with system privileges, because you have to use like the Microsoft protected storage logic, and that's tied to the actual process that it runs, and you can't change that in the existing process. So you have to have like many processes running in different contexts to be able to do that. Nyberg says it's what put you on Santa's naughty list that year. Yeah, maybe. Yeah, it's fun. But it's so much fun to, when stuff like that works, it's so much fun to do. There's like this blockchain thing that I discovered a few years ago that I thought was really cool called Wax. And I made some smart contract stuff, etc. But they have like a wallet that is a desktop application. And I don't know what prompted me to look into it, but I was like, I wanted to see if I could extract like the private keys and stuff from that wallet. I did some security testing, so I checked one of the web wallets from the chain, managed to break that, and then it was like the most common hardware or desktop wallet. I wanted to see how well that was protected, and that was like an Electron app. If you don't know, Electron is like a basically a browser, right? It's a website, but they hide some stuff so that it doesn't really look like a website. Discord is also an Electron app. VS Code is an Electron app. Lots of programs are basically just websites in a shell with some extra stuff sprinkled on top of it. So they did stuff like they have a really weird JavaScript library that does triple dash encryption, and it does it in a non-standard way. So if you try to recreate what they do, all the other implementations out there just throw or corrupt the data, but their version has like a way to overrun a certain thing and still keep going. So it's like a broken implementation of triple dash, but you need it to decrypt it. So I was like, I made something that would take a memory dump of the whole program while it's running, when you have the app open and ready to sign stuff. And then I searched the entire memory space for certain signatures of how they would store their encrypted data, the decryption keys. And then I had to build like a JavaScript VM to run that specific JavaScript version of, because I tried to re-implement that triple dash library in C#, but it was like, it was so much work and there were so many weird things in there that I was like, okay, you know what? I'll just use like a JavaScript VM to run that actual code with the data that I need so that I can decrypt that stuff. And yeah, I was able to actually extract and decrypt all the keys, and it was really cool to do. But I was also like, I don't think that I can share much of this because people will get all their stuff stolen. So, but I really love doing stuff like that. Yeah. So if I had more time, I would probably go back again and try to defeat Chrome's protected storage solutions again. But yeah. Yeah, Luke. So yeah, back to day 13. Did I set the program again? So yeah. Let's see. We were doing this. They have the input there. So I think this one should now be correct. So if I run this, it should show that input there. Yep, you can see it. 1362. So that's the input. Boom, 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 boom. Okay. What was the test version? Did they set one for test? Oh yeah, the favorite number for that one is this. Okay. So if it's the test one, it's this. So now we can do int favorite number is input to number. This was unsigned, probably uint, right? Or ulong? I don't even know. What did toNumber do? Ah, I did toNumber. That's not it. What did it output? Along, just along. Okay, that's funny because I don't have actual support for negative numbers, but it's fine. Boom. So we can do that. Actually, that should be in prepare input, and I can do console.writeLine. Let's see. We have the raw number, favorite number. Then we can do favorite number toString, and this would be B. This is 64 bits. Not sure if I want to address it like this. Bits set. I should probably make, because it's such a small number, I should just make this a short, actually. Short. That makes it a bit more displayable with 16 bits, you know. And then we do bit operations dot pop count favorite number, and this probably needs to be converted to uint, and that should work. Okay, so if we do this now, we have this one set. So now we should get blah. I need to remove the dollar. 2-bit set, that's correct. I need to remove the dollar here. Like this. As you can tell, I've been doing lots of JavaScript stuff lately, so yeah. False, let's do the false number. Let's see how many bits are set there, if that also matches. I think it's all okay, but yeah. So we have 1, 2, 3, 4, 5, 6, 7. Okay. So yeah, this is an easy way to get the number of bits set. So that's cool. Boom. Now, what was the actual challenge? This one. Find the binary representation of an. Oh yeah, okay. So we can do ulong. Yeah, sure. Magic and x and y. So we do. We can just do this. And I wonder if I need to do any braces, because the way that it's written out makes me think that there might be a precedence issue here. Probably not, but I'm not taking any chances. And I need to do what's the matter? You know what? I'll just make this ulong so I cast it when going in so that the math becomes easier. I could have just done this and then it should have also been okay, but that's fine. So let me just test. Made no difference. And let me just make this an equality thing here. So let me put this in here. Like that. And then we put the same thing here. Just for my own peace of mind, I want to know. So let's see, console.writeLine, and we do magic for 1 and 2. Made no difference. Okay, so I didn't need to do that. It will process it in the way that it needed, so I can remove all the braces there, so that is fine. Okay. Like this. Okay. Then there was the matter of the sum is referring to this. It's weird that they put this in between, or am I wrong there? Oh no, you find this and then you add that, and that's the okay. So we do this plus favorite number. Okay, that's the magic part. Okay, and then we do the same thing here. If it's even, it's open. So bool is open, u long x, u long y, and then we do bar magic is magic y, bits set is bit operation popcorn magic, and then we do return bar is open is bits set to equals 0, return is open. All right, this is basically the logic for that part. I could just make this into, you could just do this as a one-liner, right? You could just do like, instead of this, you just do boom, like this, and same for this one, but it's okay. Boom, 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 boom. So the logic is this. For example, if the 10 drawing, sure. Okay, let me see. If you wanted to reach this one, the shortest route is there, okay. These are also things that we need to put in. Let's see. Grid location, target path. So I can do. Here we can do target path is this, and now it's just passing. Yeah, wrong place. Target path is. Let's see. They wanted to know 7.4. This is in YX. Okay, 4.7. Good to know. Forgot about that. Don't know why I did YX, but there was probably a good reason for it way back when. Grid location there. Else, oh, target. So I need to swap these over as well. Okay, so that's noted down there as well. 9 said this is 2016, so it's possible it's the first AOC puzzle ever asking for the shortened path to anything. I'm not sure whether 2015 had one already. I'm also not sure. I did 2015. At least I think I went back to go do that. Yeah, I finished 2015, but I don't remember much of it. It's been a while, and I'm not sure. There's 2015, only a few days in here. So I started out doing that one, I think, in like the developer console as well, like in the browser, something like that. Because I think I finished 2019, or at least as far as I could come there, and I think I did most of this in the. Actually, I did part of this in the browser probably. Doesn't matter. Either way, let's see. So there's multiple stages. I think we've got this one right now. So I should probably do like a map and print it out just for fun. So let's do void print map int rows int goals. So we can do for int I is int row is 0, sure, row smaller than rows, increment row, and then we do for int call is 0 goals, yes, console.writeLine, and another one at the end, and blim, blim, blim. So now we can do console.write is open xy. And what do we do there? I think we can just do, I can just do period and hash, like the example, that's fine. Let's make it easy on myself. What's the issue? Oh yeah, call row. That's the thing. So I can now do print map 10, 10. Okay. Didn't I do right instead of right line here? My bad. Let's run this again. Okay, so now this should be somewhat, it's from the, it will be flipped from this one actually, or not. No, it's fine. Yeah, it will be inverted because my 0, 0, 0 will be here and then it goes down. So it will be flipped. And it's incorrect, I think. Let me see. And did I disable test? Yeah. I need to set test here. And I should probably do the row in reverse count here, just for reasons. Did they start? Did they make it 1 based? No, because they said you start at 1 1 there. Okay. Rows minus 1 bar equals 0. So this one should at least bring it in the same direction as the other one. What did I do? Let's see. Did I update? The magic number is still there. Let's see. Test is true. Why is the magic number? Ah, I'm an idiot. But we already knew that. No, that's not true. It is true, but let's do this here. Looks like it's mirrored. Yeah, but this favorite number should be 10. Yes. So why did it? Oh, I had this one here. Okay. Let's see. It's completely flipped now. In both directions. Interesting. No, that's also not true. It's just not correct. No, I was wrong to invert it there, by the way, because they also go from top down. Wait, what? Okay. It's going great so far. Where is the breakpoint here? Debug, window, breakpoints. Not sure what it is, but we'll just remove all of them. Actually, we just do delete all breakpoints. Sure. Let's run. Okay. Okay, this looks more like it. But not quite. Oh no, I'm just doing, I'm doing 6 by, I'm doing 10 by 10, but I forgot that I don't. Yeah, that's my bad. I should have only done 7 rows just for the visual. So at least now it should match the pretty picture here. Okay, sorry for that. It's hard to ignore all the extra stuff when you're trying to check if everything lines up. Okay. Marta says, if you want the key shortcut, Ctrl-Shift-F9 removes the breakpoint. Ah, okay. I don't do that often to delete all breakpoints. There's also a menu item in the debug, I know, but this was a weird case where like a debug, this was a bug in Visual Studio where a debug went to a code point that no longer existed, but somehow it hasn't updated the reference, so it breaks in a weird way. I haven't had that in quite some time. So yeah, now we have this thing. And the cool thing is we don't need to generate a sparse map. We can just always just test this. Martin says, I remove breakpoints like 2 times an hour. Okay. It's muscle memory for you. Yeah. I do the F9 toggle a lot, but I never do anything other than that with breakpoints usually. So now this is just basically with a priority queue, just find the shortest path. That's very doable. So yeah, we validated that this is correct, so that is fine. So we can do if debug, we do the print map. No, test was the thing that we wanted to do there. Okay. Okay. So we can do. Did I set my target there? Yes, we did. Okay. So let's do grid location current is new 1,1. This is the starting position. Like this. Priority queue. Doesn't take this right, and then it just needs new like this, and it needs a priority which is it's just fine, it's an int. So we can do q.mq. This would be sure q.mq current 0. And then what we need to do is keep track, hash set grid location visited this. This one would be current. It starts out there. And then we do while q.count live is 0 for task is q.tq. And boom, 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 boom. I'll just do the same thing like this here. And then we do if task plus div dot up. Oh, what did I do? Okay. We can do a function that does the checking. Do func grid location bool is valid is option, and then we do not visited contains option, and no is open option. And let's make an overload that takes a grid location here. Like this. We need to cast them to ulong because I didn't want to cast it somewhere else. So that is also fine. Take the pane here. So now we check if we haven't visited that one and that one. I do this in a separate function because I combine two values to create a temporary value that I don't want to store in a thing. Actually, I can do this. Just try visit. So I can just do no, bool is okay. So I can do try visit like this. So we can do if this visited.add option. At least it's queued, so that's fine. Do I need to do it there? Yes, it's fine. And we need to do q.enqueue option. Something like that. Actually, it would just be task.length steps actually. This one. Possible use of unassigned field. Okay. Now it's assigned to null. No, it doesn't like that. Okay. Jesus. No. Does it take that? Sure. Return true. Return false. Something like this. Boom, 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 boom. Yeah, that would be good. I wonder if it's worth it for the isOpen function to have a cache there so that we don't have to do the math. I'm gonna leave it to just do the math for now, but we can try later. Like, okay, to do how much faster with a lookup cache. So that's fine. So now we can do try visit task dot next plus dir plus up. And we also need to account for negative values. So we need to also make sure option dot column larger equals 0 and option dot row larger equals 0, and then we do the rest. So we do this in order of how hard it is or how heavy the operation is, probably. And I don't know if this one or this one is heavier, so we'll figure that out later. So this one will do that. And here we need to check if task dot next equals target path, and then we break console p1 equals task dot steps console dot write line found our target in blah steps. Actually p1 steps in this case. Okay, so let's run this, see if this works. P1 is 0, cool. Let's step through this to make sure that it, to see what's wrong. I have it shifted over to, that might have been part of the issue. I had it shifted over. Let's see. So let's see. Column is 1, row is 0. Visited, I mean, did we print the map? Okay. So yeah, this one should be there. Wait. No, that's correct. Actually, let's see. So we start at 1, 1, which would be here. So 2, 1 is there. But 1, 2 should be open. This one should be open. Yeah, this one should be open. Cool. We add that one. Oh, and QD. Okay. Not sure why I didn't see that, but that makes no sense. Okay, so I did part 1 correctly in 1 step. Okay, so let's now try the real input. Okay. I need to clear this because it didn't. Boom, 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 boom. So what do we do for part 1? 0. Okay. Interesting. Did I do something wrong there? Let's see. Starting from this one. 7, 7. Okay. Console, that my line. Exploring blah. So this one will be option dot call. So this will be an XY notation, option dot row. So let's see which things it tries. So it tries 1, 2, 3, 4 of them before it dies. So let's try to print the path. Else, let's print a, let's do a 7 by 7 and see how that looks. So we start off at a, so that is probably wrong. Wait. Aha. That's my 2-number thing biting me in the behind again. Because it takes a new line here. Cool. I shouldn't use the 2-number thing. Okay, so it's 82. To explain, my 2-number just shifts it over, expecting only like ASCII character numbers, and it had the new line in there, so it made a bigger number that there should be. Woohoo! Part 1 done. Part 2. How many locations, distinct XY coordinates, including your starting location, can you reach in at most 50 steps? Okay. That's just cool. That's basically just this, and just keep going. The thing is, there are 2 ways to do this. Because you can do basically a flood fill here, but I can just use the same thing. Now, I'm making this harder than it needs to be. So let me just copy this. There are a few fun ways how you can do this, but it's fine. Let me just do the stupid one first. So let's do 82. Do they even have a test value? No, they don't have a test value. Cool. So we don't care about this one. And in this case, we just keep going until we hit 50. Okay, like this one. If task.steps larger or equal to 50, then we stop here. So we don't care about this at all. We just return true until we don't return true. Or let's just do return true in this case, and we do return false. If, like this, we say, actually we can do that here. Yeah, like this. We can just add ifs here and break if it returns true, which means that we've gotten to our level 50. We can visit visited.count places in a max of 50 steps, like this. And here we can just set p2 equals to visited.count. So this is part 2. Let's see. And for part 2 we have 138. Woohoo! Nice. Okay. What I was trying to say is that you could just build the map and not even do the pathfinding and do a flood fill. But yeah, it's fine. It's fine. Thanks for the stars. Yeah, this one was nice and easy. Okay. Cool. This one was fun, I have to admit. So let me clean up just a little bit here. I'm still wondering that, but let's just remove all of this stuff. I got the budget stars from Luc. Boom. Yeah, I think this is fine. I need to put in the answer for P2 here. Let's do true. Let me just run the same for part 2 so I can just fill in the answer so that it satisfies the test, even though it's not given. So now all the tests should complete. Bloop. Okay. The exploring thing can be removed. We don't need that at all. Yay, done. Okay, cool. Okay, cool. I'm gonna take a peek at 14. Since we've done so quickly, I don't want to stream till too late today, but I think we can do at least take a look at another one, right? So let me update. Gives me a reason to update the stream title. Keep everything current on Twitch. Don't think you can do that on YouTube. Cool. Now the title should be ready again. Let's see. One-time pad. In order to communicate securely with Santa while you're on this mission, you've been using a one-time pad that you generate using a pre-agreed algorithm. Unfortunately, you've run out of keys in your one-time pad, so you need to generate some more. To generate keys, you first get a stream of random data by taking the MD5 of a pre-arranged salt, your puzzle input, and an increasing integer index starting with 0 and represented in decimal. The resulting MD5 hash should be presented as a string of lowercase hexadecimal digits. However, not all of these MD5 hashes are keys, and you need 64 new keys for your one-time pad. A hash is a key only if it contains 3 of the same characters in a row, like 777. Only consider the first such triplet in a hash. One of the next 1000 hashes in the stream contains that same character 5 times in a row. Okay. Damn. So we try to attack MD5 hashing or something. Considering future hashes for 5-of-a-kind sequences does not cause those hashes to be skipped. Instead, regardless of whether the current hash is a key, always resume testing for keys starting with the very next hash. For example, if the prearranged salt is ABC, the first index, which produces a triple index, is 18 because the MD5 hash of ABC18 contains blah blah blah. However, index 18 does not count as a key for your one-time pad because none of the next 1000 hashes contain that. Okay. The next index, which produces a triplet, is 39. The hash of ABC blah blah contains EEE. It is also the first key. One of the next 1000 hashes, the one at index 816, contains that. Okay. None of the next 6 triplets are keys, but the one after that at index 92 is. It contains 9999 and index 200 contains that. Okay. Eventually, index blah 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 meets all of the criteria to generate the 64th key. Okay. So that's 23,000 and then up to 1,000,000 of hashes, and Jesus. Do I need to whip out some GPUs? So using our example of salt ABC, index 22728 produces the 64th key. Given the actual salt in your puzzle input, what index produces your 61st one-time key? Your puzzle input is that. Okay. Okay, this is a spicy one. I wonder if there's like an attack that we can exploit, but This is outside of the scope, I think. I have already created 14. So let me set up day 15. Move this one over 1 day. 14. I think they said, was it ABC? Yeah. So this would be the salt, the test salt, and I think this is really spicy. Let's see. What was the logic again? You take the so you MD5 hash this, okay. Okay. So it got you interested, yeah. Long index is 0. While true. Let's see, MD5. Hash data. I can just do ASCII get bytes. There will be hash and the input followed by index. So this would be pretty sure I have a helper. This is not hex. This is binary. Great naming. Let's see. No. I'm surprised that I didn't do. I mean, I could do 2 string like base 16, but convert to hex string. Do we care if it's lower or upper? No. String hex, so we could do hex is this. Do we only need to consider the first triplet? The first such triplet in a hash, okay. Oh, we can, let's say, yeah, okay, so this is look ahead, so we need to cache this. That's the trick here, never mind. It's not as difficult as I thought. I'm a bit of an idiot, sorry. So we need to do string get hash ulong index. So we have a dictionary of ulong. And I should probably not make this too, I can just, let's do uint and see if we can get there. Can always upgrade later. This just makes the search smaller. String cache like this. If not, try cache, try get value, index out string result. Result is this. Cache of add this, return result, right? Converting null letter operator, what? No. F that. Can I do this so that it will, no, okay. Just don't complain, it's fine. And this becomes index like this. So we do get hash index like this. Now we do for int I is 0. It's 32, right? Yeah, okay. Just wanted to make sure. This would actually just go up to 29. So if hex I equals, come on. Boom, 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 boom. Let's see. We need to also do the next one. Else we increment I to just do an extra step. Skip an extra one since this chain is broken. Right? If there are two repeating ones, but the third one doesn't match, we can skip an extra one. So like this. So let's see, char to find no, actually. Okay. We reset every time. Come on. So we can do actually just char get first triplet string value. Like this. Boom. So we can do it differently now. So we can do to find equals get first triplet hex. And then we do if to find hash value. Now find is it quintuplet? Something like that, right? Let me think. I should probably also make this get repeat int n. So for int j equals 0, j smaller than n minus 1 increment j. Let's see, so we do char candidate like this. Candidate is value I. Then we do this one here. If value I plus j, so this would actually just be 1 and then smaller than n, that also works, equals candidate. If it doesn't equal candidate, we do I plus equals j minus 1, yes. Bum, 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 bum. No, this doesn't work. I need to break here. And I also need to set it, okay, bool, so here we do end equals 32 minus n. Here we set all okay to true. We do all okay as false. If all okay, return candidate. Okay, I think this one is correct. Let's test this out, because I've written a lot of stuff. Let's make sure that it works. So console.writeLine, no, not window height, writeLine. Let's do get repeat for this, and we want to find 3 of them. So this would be 1, 2, 3, A, 1, 2, 3. Okay, and we want to do this with 4, and then increase B. What's happened? What happens if I run this? Index was outside the bounds of the array. That's cool. N is 28. J is this one. N is 4. So it needs to be this then. Okay. Precedence. I'm an idiot. Okay, let's try this again. Cool. That's interesting. 8. Ah. Never mind. I think this should then be it, right? Okay. Cool, so we have A and then B. So for everything that we've put in here, it finds A there. It doesn't find anything with 4. And for the last one, it finds B there. So that is cool. Okay. So that logic works. Cool. Actually, let me just make sure that it also finds it at the end. Haha, off by 1. See? Ba-dum-bum-bum. So is it this? Do I bring another arrow in now? No, that was it. Okay, never mind. So it's actually like this. Because we need to stop one less than the length that we're looking for. Oh, wait. Oh, yeah. Same thing as before. Now it works. Okay. Cool. Got there in the end. So the value.length here we can put in 32, but I don't think that's something we need to worry about too much. So we have something here, and then we need to find the next 1,000 one. So we do for int I is 0, I smaller than 1,000, increment I. Let's see. Contains, okay, so we need to look for a specific character in the repeat thing as well. So, so here it's a bit different because we need to find a certain character as well. If candidate equals C, actually we can do this differently. We can do, if it doesn't equal C, we do continue. So we shortcut here and only do the rest. And in this case, if all okay, we return I. In this case, this will be the index where we find it. And otherwise, we return 0. Okay. So now we need to do int repeat index equals get repeat index. This will be to find that value. First we need to pull in the hex string there, and we need to find 5 of them. So this one will be get hex or get hash, which would be index plus I. Uint. Okay, I'll make this a uint. So now the code is happy. If repeat index has value break. Okay, now I think we needed to do this like 60. What was the flow here? Okay, so it's just find one. So this one would be the thing. Okay, and which is the index that we need? None of the next 6 triplets are keys, but the one after that index 2 is 6 triplets. Wait, 6. Okay, 64 hash is okay. Considering the future hashes for 5 account sequence, does not cause a always from some testing key starting with the very next hash. Wait, continue future hashes. Yeah, okay, you just start at the next index there. Sure. Yeah, you need to find 64 of them. Okay. Okay, so let's do dictionary. No, list of int triplet, int quintuplet. Gonna look it up if it's the name is correct. Keys is blah. 5. Okay. It's for 5 children, but it's fine. So now we do keys.add. Index followed by repeat index dot value. No, this would be I. Since we don't even care, we can just break here and let's make this uint so that everything is happy. We don't even care if we found it, we just need to go on to the next one. We can just stop if we're short of 1,000. So, and this one is the same here. Now we can do P1, actually, no, if keys that count equals 64, P1 equals index, something like this. And here I can do if P1, actually I can do the while here. So I can do while P1 equals 0L. That's our condition, so we break there. Oh. Index this. Yes, okay. So let's run this and see if we get into an infinite loop or not. Should be fine. I get a different number. So I get index 20,371. So I'm now curious to see what the indices are. So, actually I can just also do this. console.writeLine. So index triplet is to find a value. Repeat index of value. Yes. Let's run this. So we have something to compare against. So it doesn't find 18, but it does find 39, which is interesting. The index for next group is 39, right? Ah, none of the next out. Okay, so that is correct. So here, I needed to write out the other index there, not repeat index, but I. So that will be the offset value. I think I already know the issue because I started the same thing. Yeah, because this needs to be, it starts at 1 and it needs to be like this. So I'm pretty sure that now I'll get a different value. And now my test runs. Okay, so the issue there was that I considered the same entry for the 5 runner as well, and that was the bug. So that is cool. We found them all. So now I can remove this part here. And now I need to do the real input. So let's do false here. False. Let's run this. Okay, that wasn't too bad. Not the right answer. Answer is too low. Okay. Which is weird. Because we found our answer. Did I? What is my hash? Is it clear? I know what it is. See, there's a new line at the end. Input is input.trim. Let's run this again. It's always the trimming that bites me in the behind. Now this will be too fast. Yeah, I hate having to wait after a submission. Are we having fun still? Yes. Woohoo! Another gold star in the bag. Let's see. Part 2. Of course, in order to make this process even more secure, you've also implemented key stretching. Key stretching forces attackers to spend more time generating hashes. Unfortunately, it forces everyone else to spend more time too. To implement key stretching, whenever you generate a hash, before you use it, you first find the MD5 hash of that hash. Then use the MD5 hash of that hash, and so on. For a total of 2016 additional hashings. Always use lowercase hexadecimal representations of hashes. Okay, I need to fix that because I didn't do that. Let me just quickly make sure that I do that now before I forget later on. To hex string lowercase, okay. Fixed. So this is basically the idea behind PBKDF2, etc. You just have multiple iterations like script and bcrypt. They do this and it prevents dictionary attacks. So nice. Everybody's still having fun. Nice. So yeah, this is fine. Okay. Let's see. So this is for the test. So answer P2. I still need to record my answer actually. Like this. Boom. Answer P1. So now we do it. this will be actually, we don't need to make it larger than that. That is fine. Boom, 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 boom. Like this. So now we can do it KS, and this will be this. Just fine. And now we do for int I is 1, I smaller than iterations, I. Result is wow. We can also just short circuit this actually. So we can do byte like this. So we don't do the extra toString stuff, it's not needed at all. So we can do hash just like this. Mate says, went AFK for 2 minutes, you've got to start? Yes, I did. The second part is basically the same to like bcrypt and scrypt, like doing multiple iterations of the same hash. The hash count is 2016, I think, yes. So. Like this. That is fine. I'm just writing now the recursive function that takes in an arbitrary number of iterations there. So for everything past the first one, we add this one. And then we need to make sure that it's lowercase. But yeah, that should be fine. Oh no, actually I was wrong because they want us to hash the they do want us to hash the string representation of the thing here, so I'm wrong. So this would be, I do need to convert it into text, which is a bit of a shame, but it's fine. Is fine. Yeah, it's fine. This will be cache KS, and we do the key becomes iterations like this. Okay. And now basically this all becomes the same, except we do this for part 2. Well, P2 equals to 0, and in this one we do the like this. Oh yeah, I need to make this a const u short like this. Let's see, part 2. Yeah. I should run the test first, actually. Oh, it doesn't like that. It becomes very slow. True. Let's see. Did I do it correctly? No. 13,000. Let me check this. Hex string lower. Yeah, that is the thing that we needed to do. Let me just check the first time that we do this that it's correct. A B C D. It's switch star. Yeah, there. So like the index is, why is index 19? Why does it start at 19? Let's see. Ah, because I'm not so smart. Hash iterations like this. So now index should be 0. So that should be A3. No. What did it say here? 577. Okay, so that is the correct one. Since I need to do this every time anyways, I can just do it like this. Like this. It's probably off by 1 here, but oh yeah, it's this one for sure. Two string, pad left, 5. Like this. Actually, it only needs 4 because you never go past that one. 2. Yeah, let's stop before it runs, but I think this one is the issue here. Bloop. So now the last one should match A1. Why does it say 4? Do you want 4,000? Wait, 2016. Wait, what? Oh, this should have been a 0. Okay, never mind. Boom, 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 boom. That was confusing as... Okay, let's go back to the beginning and look if it's correct. So we start at 5, now we do the ECC and then 160. So okay, so that is fine, but we don't end up with the A1 thing here. Why doesn't it end up there? 20 additional. Okay, so I should, if I do it one more time, like this one, set next statement. That's 6, 5. No, that's also not correct. 6, 8. I mean, it would be like this. Yeah, because you don't need that. So it starts at this one and then it does these many extra. I only wanted 4 of these. You know what, let me just add a few more. Oh, didn't I set a breakpoint? Okay. Also, the first, I wonder if I needed to do it the first time as well. Wait, this is weird. Now it says A10, right? Okay, I'm not sure what I changed. Let's put it back. Oh, I closed Advent of Code. That's also fine. So is it correct now? Does it end up the last one? Okay, it needs to do one more there. Okay. Oh yeah, because I need to do smaller equal to. So this is the initial one. Do I write? Let's see. I write it before I do it again. So that's not smart. This one was correct, but my console write line there was wrong. Okay, great job so far. Let's see. So now, do we have the test? Yes. Okay, let's see if we run the test correctly now. Okay, part 1 is correct. What does part 2 do? It's not very fast. And this is with caching. Test is set to true, but I get a different number. 22,551. What would be the reason for that? Oh, it was correct. I just set my test value wrong. Answer P2 test is this one. Okay, false. So the code is correct now. It's just it takes a little bit of time. Actually, I think we can skip the whole from and to hex. Or no. That's close. Woohoo! Done it. Nice. Ha ha ha. It works. It's done. It's all good. Nice. So was there a because something in my mind tells me, but I think because they want to hash the the string representation of the hex, that you can't cheat on that, right? Because this adds a bit of latency, but we also already have the cache here, so it's a bit too slow for my liking, but Nightbear says you can't really optimize this as far as I know. Okay. Okay, then we done all we did. Mine also runs 10 seconds. Okay, nice. Okay. So, do we know if 15 is quick or not? Like, if I can do this in 30, 40 minutes, I might want to do this as well. In 2016, people reported optimized runtimes close to a minute. Okay. Well, I guess I'm not doing that bad then. Boom, 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 boom. Maybe I'll try part 1 for this one. Ninebear says the only way to get it down is by using multiple threads in parallel. Yeah, I didn't even think about that, because you already know that you need to do a pretty broad search space. So run it on the GPU. Yeah. Let's see what this one is about. Day 15. Now, you know what? Let me update Twitch again. I like that you can update this in Twitch. Boom. Day 15. Timing is everything. The halls open into an interior plaza containing a large kinetic sculpture. The sculpture is in a sealed enclosure and seems to involve a set of identical spherical capsules that are carried to the top and allowed to bounce through the maze of spinning pieces. Part of the sculpture is even interactive. When a button is pressed, the capsule is dropped and tries to fall through slots in a set of rotating discs to finally go through a little hole at the bottom and come out of the sculpture. If any of the slots aren't aligned with the capsule as it passes, the capsule bounces off the disc and soars away. You feel compelled to get one of the capsules. The discs pause their motion each second and come in different sizes. They seem to each have a fixed number of positions at which they stop. You decide to call the positions with the slot 0 and count up for each position it reaches next. Furthermore, the discs are spaced out so that after you push the button, 1 second elapses before the first disc is reached, and so on. And 1 second elapses before as the capsule passes from one disc to the one below it. So, if you push the button at time is 100, and the capsule reaches the top disc at time is 101, the second disc at time 102, the third disc at time 103, and so on. Okay. The button will only drop a capsule at an integer time, no fractional seconds allowed. For example, at time is 0, suppose you see the following arrangement. This 5 has 5 positions. At time 0 it is at position 4. Sure, if you press the button exactly at time 0, the capsule would start to fall. It would reach the first disc at time is 1. Since the first disc was at position 4 at time 0, by time 1 it has ticked 1 position forward. At the 5 position disc, the next position is 0, and the capsule falls through the slot. Okay. Then at time is 2, the capsule reaches the second disc has ticked forward 2 positions at this point. It starts at position 1, then counted to position 0, and finally ended up at position 1 again. Because there's only a slot at position 0, the capsule bounces away. However, if you wait until time is 5 to push the button, when the capsule reaches each disc, the first disc will have ticked for... this is like a GCD problem, probably, like having common divisors and, you know. If, however, you wait until time is 5 to push the button, then when the capsule reaches each disc, the first disc will have ticked forward. 5 plus 1 is 6, times to position 0. And the second disk will have ticked forward 5 plus 2 is 7 times, also position 0. In this case, the capsule would fall through the disk and come out of the machine. However, your situation has more than 2 disks. You noted their positions in your puzzle input. What is the first time you can press the button to get a capsule? Okay. We should parse this. Actually, I'm just doing this so that I can note if there is a difference there. Probably not, but I want to make sure. So these are all incremental, so we don't care about those at all. This is all the same, so we only care about this digit and this digit. So prepare input means input 2 lines. Select. Now we want to have index 0, 1, 2, 3, and then 4, 5, 6, 7, 8, 9, 10, 11. 3 and the last one basically. Like this. String line in this. It's fine. String parts is line dot trim end split. Sure, and then we have int positions is parts. Const int positions index is 0, 1, 2, 3. We don't care about the last one actually. So this will be positions index to number. That's fine. And then we have int current position is parts 1 to number. Like this. That's basically a shortcut for the last position. So we do list of int positions, int current position, disks, like this. We can do this dot add positions current position. And now we can do for each bar disk and disks console right line. Disk index plus 1 has disk value dot positions disk value dot current position. Okay, So now we should be able to recreate the input. Disk 1 has 5 positions, time position 4 and 1. Okay, so that's the input parsed. Don't care about that. Can move this up here. Times 5 was the test input. And like this is a variation of that problem, and I don't remember, but there is a way to get like the greatest common divisor with offset. It's basically the thing, and I don't remember it. Because it's pretty sure it's this one. Nope. Probably not in something here. What thing is this? 2025 day 10. That's not it. But yeah, we'll cross that bridge when we get there. Chinese remainder theorem, you mean? But the numbers here are small enough so it could solve it. Well, okay. Yeah, I don't fully remember, but I remember that there was a thing where you have to do basically the GCD, but because there were offsets, there was an issue, and yeah, that might be the Chinese remainder theorem. And I clearly didn't grasp it back then. I had to Google it as well. But yeah, let's try. So we do int time is 0, while true. Always scary to do while true. Should always do a sanity. Const int max loop count is, let's do 1,000,000 int loop count. Let me think. Because basically you need to have like an index plus 1 for the time, and then you add that to this one. So at disk 1, it will be at position 0. Okay. So basically, you do for int I is 1, I smaller than, no, wait. Because this is offset, and then you need to know how many times you can do it. Basically, you need to have the max of all the lengths there. Int max is disks.max positions. Basically, this is the amount of times minus 1 that you need to go. So we do for int I is 0. No, smaller than max increment I. So this is relative to the time. Actually, I can do it differently. It's fine. I can increment two things. It's fine. It's fine. It's fine. No. Do. We'll do it in a nice way. While plus time smaller than max time. So we do here max time is 1,000,000, like this. So now we need to calculate the offset. So we do this all d let's do it like this. We want also index, and we have this one based, so like disk number, this is one base because this is also like the time that you need to add to the current time to know when you process it. So we need to do disks dot all d, so this becomes d dot index plus d dot current position plus time mod d dot positions larger than 0. Console, that right line. Let's record the time. We don't even need to do this because we just need to evaluate every disk like this. And then we can do break. At 5, was that correct? Time is 5, cool. Cool, that works. It's always nice when you program a bunch and then it works in one shot. Let's see if it also works for the real thing. And here I need to do P1 is time. So let's run this. Boom. Woohoo! That was fairly easy. Part 2. After getting the first capsule, it contained a star. What a great fortune. The machine detects your success and begins to rearrange itself. When it's done, the disks are back to their original configuration as if it were time 0 again. But a new disk with 11 positions and starting at position 0 had appeared exactly 1 second below the previous bottom disk. Wait, what? With this new disk, and counting again, starting from time 0 with the configuration in your puzzle input, what's the first time we can press the button to get another capsule? So 11:0, we add that, right? So part 2, we do this.add 11:0 this.count plus 1. Okay. Amata says at this point, I'm not sure you're sick, you're going too fast. Sorry. Sorry if I'm spoiling the fun by making it work. Let's see. Not sure if I understood fully correctly, but let's run this and see if it does. They don't give a test input there, so Yeah, it's probably fine. P1 is here. There is no test for P2, so let's just run it. Okay, that was very fast. And it returned 0. Cool. Ah, it exceeded the max time. So let's add 1 billion. Okay. So my upper limit of 1 million was a bit short. Woohoo! Nice. Ah, that wasn't too bad. I was too pessimistic about this one. Okay, I'm quite happy that I've done 3 days now. Now I kind of want to read day 16 as well, but I think my lucky streak will end soon. I think I'll leave this for the... It looks fun though. But I think I need to make my wife happy and just be home a bit earlier today. I think we've done 3 days, that's good enough. And I'll save this one for the next time, right? So I hope you had fun. I talked to Luc. He's talking me into maybe streaming while I'm working on my web hosting company, but I've also accepted a sort of like rush job where I have to do a lot of work in a short time, so I probably don't have much time to work on my company. But would you guys like it if I would stream part of the regular work when I would just be like building web components, working on my CMS and stuff like that? Is that something that you would also be into, even if that would include HTML, JavaScript, also .NET code, but like actual work, so that you can keep me company and chat a bit while I'm working? If you're up for that, I might stream a bit more, but no promises. So yeah, let's see if we can raid somebody. There's only so much time left to watch Twitch. Yeah. I'm just wondering, like, I really appreciate you guys showing up. It's nice. I just wonder if what the content is that you would like to see. If it's mostly just the advent of code stuff, or is it more general programming as well? Yeah. Let's see. No. I want to jump in the software and game dev category first. Let's see. Do you guys have a preference? This is German. I should not do that. Boom, 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 boom. Coding. This is also German. Marta says, I'm with Ninebear here. Depends on the time of the day. I mean, I'd love to watch it, but I might not have time. People in the office would give me weird looks. Yeah. Yeah, but Luke would watch like a big... Oh, wow, that's loud. Okay. Okay, I'm just gonna rate him again. Seems like a good dude. And just say hi, so I might stream a bit in the future, but I'm not sure when. But I'll try to keep the Tuesdays up at least. I hope you guys had fun. Bye-bye.
3. Wait, what else do I need? Flag path. Oh, the force. I don't want that yet. NKCSS Nick, how are you doing? Welcome in. What were you working on? What were you doing?